Hello, welcome back. I'm Andreas, your tech-curious web designer. In the last two videos, we Dockerized our Django application and a Postgres database. In this video, we will set up a complete background task system with Celery, and at the end of it, we will have 6 services running in containers at the same time, including a Celery worker, Redis, Flower, and Pete. Here is where Docker really shines, because with a Docker Compose file, we can manage all the services with just one single file and command. But before we get started, if you like this content, give this video a thumbs up, subscribe to this channel, and support me on Patreon. Thank you so much. I really appreciate you. And now, without further ado, let's dive in. In this tutorial, we will Dockerize a Celery ecosystem, which I explored already in my background task series. So if you want to learn more about Celery and background tasks, check out that series as well. You can find a link in the description below. This is a quick overview of what we're going to build today. We start with the host app, which contains the base code. We create a Docker file, which is the blueprint to build our Django app Docker image. Then we create a Docker Compose file with the configurations to run all our services inside containers. Then with the Docker Compose build command, we build the images we need. For this project, we're working with a Redis, Postgres, and our app image. And with the Docker Compose app command, we build a project, also called a Docker network, and create all the containers. In this project, we have our app container, Postgres, Redis, as well as Celery to set up background tasks, Flower for real-time monitoring, and Pete for periodic tasks. And we start up and run all those services at the same time. When the containers are up and running, we can access the app through the web browser. Setting up the system might be a bit daunting at first. However, once done, working with multiple containers at the same time is very simple and only takes one command from the terminal or one click from the Docker desktop. Okay, let's get started now. In the last video, we connected our app already to a Postgres database running inside a Docker container. Let's continue now by creating a Docker file to containerize our Django app as well. We created this Docker file for our app already in part 1 of this series, but should you not have it, we can recreate it now. So we go to the root of our project and create this Docker file. The code for this file you can grab from my GitHub repository at github.com/ndchat/docker. Click on Docker file and copy the code. This describes how to build our Django app and has also the command to run it. However, we will use this image also to run our Celery services, each with their own start commands, and we define those commands in the Docker Compose file, which will override this command defined here. So we could leave the command here as a default, but I will get rid of it, because we actually don't need it. Okay, save this file. We can close it. I will also create a docker ignore file to ignore the files and folders we don't need in the container. You can grab the code again from the repository. This includes, for example, the environment variables or the virtual environment. Now with these 2 files in place, we can containerize our Django app. And as very first, I shut down the Django run server, because from now on we will run the application from the container with the Docker Compose command. Okay, and now we set up everything in our Docker Compose file. At the very top here, I add the configuration for the app container. We used a basic setup already in the first video of this series, so let's grab the code from the repository. So Docker Compose 1. From here, I copy the code for the app service and add it in here. Okay, instead of running the docker build command to build the image from the Docker file, we can also run the docker compose build, which builds all the images defined in this file. For this, I add here the build parameter and set it to a dot, which means look for the Docker file in the root directory and build the image. The image here describes what the name will be of this Docker file, and I will call it my app image. And then for the container name, my app container. Then here I add now the command to run this container, python manage.py run server on port 8000 inside the container. And then for the ports, I map the port 8000 from the host machine to the port 8000 of the container. For the volumes, I sync everything from the project root to the app directory inside the container. And as last parameter, I define the pens on, which makes sure that my Postgres database and Redis are up and running before I run the app container. Docker reads the file from top to bottom, so we could also place the services in the correct running order, but I prefer to list the main container first, and it is a good practice to add this parameter anyway. Okay, with that we set up our app container. The Postgres container we set up already in the last video. And make sure that the Postgres driver for Django psychopg2 binary is also installed. But one thing we have to change from the last video, and this is the host for the Postgres database in the settings.py file, as we're running now the app from inside the container. We have to change here the host to Postgres, which is the name of the Postgres container. With that setting, our app container is now connected to the Postgres container. Okay, let's continue now. As next service, I add Redis. We need Redis as a message broker to run Celery. Should you be interested in an introduction to Redis, check out this video. I download the Alpine image for Redis from the Docker Hub. This is a lightweight version of Redis. Then I add the container name, my Redis container. I want Redis always to run, unless I stop it manually. So I add here the restart parameter. Then I add here the ports mapping. Redis by default uses 6379 as the port number. However, adding the ports is not actually required, as the containers within the same Docker network can communicate with each other using the container names as host names. The port mapping is primarily used to expose container ports to the host machine, for example to access it through the web browser or a CLI. We can, however, add the ports for good practice. And then I also add the Redis volume. So I call this volume Redis_data. This is something we have to declare in our volume section here, like that. And I connect it to the default location inside the container, which is /data. Okay, and in order for our Django application to talk to Redis, we need to pip install Redis. Okay. As next, let's create a Celery container and add a simple background task. If you're interested in a Celery introduction, check out this video. I call this container Celery. The image I'm using is the my app image, which we will build with the app service. We define it here. Then I add the container name, my Celery container. Then I ask the command to run the Celery worker. Then we add the volumes, which syncs the code from the host app to the app folder inside the container. However, changes to the Celery tasks need a container restart for the changes to be applied. And we can restart the container easily with the Docker desktop. and Celery depends on the Postgres, Redis, and the app container to run first. With this, the container is set up. Next, we need to pip install Celery. And to connect with the Celery container, we need to set up the Celery broker URL in the settings.py file. This is telling Celery we're using Redis as the broker and connecting to the Redis container with the port 6379. Additionally, I also configure the Celery result backend. Here I'm using the default Django DB, which is set to be the Postgres database. And Celery result extended set to true gives me more information about the background tasks. Okay, and now we need to install the Celery results package. With pip install Django Celery results. Alright. We also need to add it to our installed apps. So for this app to work, we need to migrate new tables to our database. And there are a few ways we can do those migrations. So if our app container would be already up and running, we could do this with a docker compose command in the terminal. So let me clear here first the terminal. So with docker compose exec and then the container name, we can run commands in that container. However, we don't have the app container up yet, so that won't work right now. Another way to write this command is with the Docker desktop. Here we would go to the container, but as we don't have the app container yet, I will show it with the Postgres container. Here we can see first the logs, but if you go to the exec tab, we can execute commands here inside a running Docker container. But as our app container is not yet built, we can add the migration commands in a file. This file is called entrypoint.sh and is executed when the container is built. So in my root here, I create a new file and call it entrypoint.sh. So this first line describes what shell interpreter should be used, and sh means use the default shell script. This hash symbol and exclamation mark is called the shebang and is followed by the path to the shell script. Then we can add here the make migrations command, the migrate command, and the run server command. With that, we save this file. And in the Docker Compose file, we add this file now to the command. Alright. And as last step, we need to make this file executable so that the container has actually permission to execute the commands. So we can check the permission of a file with this line. So ls lists files and -l stands for long listing format. And this basically gives us the permission information about the entrypoint.sh file. So here we see the permissions. So the first dash indicates that this is a regular file. The next three characters indicate the permissions for the owner of this file. Here R stands for read, W for write, and the last character should be a X for execute. However, it is a dash and means that this file does not have the execute permission set for the owner. Then the next three indicators define a permission for a group. In this case, a group has only the read permission. And the last three indicators are for everyone else. Let's add the execute permission now to all three classes. And this is the command to do that. Chmod stands for change mode, and +x adds the execute permission to the file for all user classes, so the owner, the group, and others. Okay, let's check now the permissions again. And as we can see, it added now the X to the owner, to the group, and 2 others. So this file is now executable by everyone. Alright, let's continue now with Celery. So the Celery container is set up, and we connected it to Redis and added a results backend. Now let's add a simple Celery background task to our Django application. For this I'm creating a celery.py file in my core folder. And we add here the Celery configurations, which you can grab again from my GitHub repository. So here we go to Celery, celery.py, and grab this code. So this code instantiates the Celery object. Okay, save this file. We also add some code to our init.py file. Get the code again from the repository. And with this code, we import the Celery object when the Django app starts running. Okay, save this file. And now let's create a simple background task. So I'm going to my home app and create here a tasks.py file. And add here a function for background task. We go to the tasks.py file, copy the code, and paste it in here. Celery is grayed out for some reason, however we pip installed Celery before, so this should still work. In this file we use a logger object to log messages to the console. If you want to know more about logging, check out this video. Then in the first function here I create a very simple loop to count from 1 to 10 in 10 seconds. And when finished, we return the string task done, which will show up in the Flower interface. And the second function we will use later for a periodic task with Beat, for example to send a newsletter. Here again I use a loop to loop through 1 to 10 and return the string completed. Let's save this file, and I create a button now to trigger this first function asynchronously from the home page. So I'm going to the views.py file and add here the function for the button. The code is in the views.py file. I copy the function and paste it in here. It takes here the count task, so let's import it. From .tasks import count task, and .delay triggers this function asynchronously as a background task with Celery. And I return here a redirect to home. Let's import redirect as well. Save this file. And now we link this function to a button on the home page. We set up the URL. And add here the path, which calls this count to 10 function with the name count. Okay, save this file. We can close it. Also the views, as well as tasks, the init file, and the Celery file. And now I'm adding this button to my home.html file. So in the templates, home.html, I'm adding here this count to 10 button. Alright, save this file. And we can close now also this file. So with that, we set up now a Celery service and added a simple background task which counts to 10. As next, let's add Flower, which gives us a real-time monitoring interface for Celery tasks. If you want to know more about Flower, check out this video. I'm using here again the my app image, container name my Flower container, then the command to run Flower, with the interface protected by a username and password authentication. Then I add here the port mapping to access this container from the web browser on port 5555. And Flower depends on Redis. We don't really need volumes here because Flower is a real-time monitoring tool and gets its data straight from Redis. Okay. And finally, we also need to add Flower to our application with pip install Flower. Alright. And the last service I will add is Beat to schedule periodic background tasks. If you want to know more about Beat, check out this video. Again, the image is my app image. Container name is my Beat container. Then here we have the command to run Beat. Then add the volumes. And this app depends on Redis and the app container. Next, let's add Beat to our project. So I clear here the terminal. Pip install Django Celery Beat. I also have to add it to installed apps, so I'm going to my settings.py file and add here Django Celery Beat. Alright, save this file. With that, we set up also Celery Beat now, and we added already the send newsletter function as a periodic task. Okay. So with that, our Docker Compose file is complete. We defined 6 services here now to run in containers. Okay, I save this file. But before we can run this file though, we need to add all the dependencies we just installed to the requirements.txt file. So again, I clear the terminal here with clear. And with pip freeze, I add all the dependencies to the requirements. Alright, and we're finally ready to run the commands. So first we run the docker compose build command to build the images we need for the containers, defined with the build parameter. Okay, let's run it.
A few moments later.
Okay, this created now our app image. Let's check it out in a Docker desktop. So if you go to images here, we can see that my app image was created. Nice.
Nice.
And now let's build the containers with Docker Compose app and I run it in the detached mode. Alright, it seems like all containers are up and running. Let's check it out. As we can see, it added here now also the Redis image. This is coming from the Docker Hub. And if we go to the containers, we can see here the containers up and running. Well, almost. The Beat container for some reason is gray and not running. Let's try to start this container manually. Great, and now also this container is running. Okay, and now the moment of truth has arrived. Let's check out the website and do some testing. To go to the website, I can click this link here. And we have our containerized app running at localhost with the port 8000. Let's log in to check the Postgres container. And now I'm logged in with my account. Nice. Now let's test the button to count to 10. That should trigger the background task. So far so good. The website refreshed as normal. Let's check the console now. So I'm going to my Celery Container console. And as we can see in the logs here, It counted indeed to 10 and logged the loop. Let's try this again and see the logging in real time. And as we can see, it is counting to 10 with 1 second sleep time after each iteration. And task completed. Perfect. Next, let's check the Flower container. We can access the Flower interface on port 5555. Here we have to sign in with the username and password. And we can see here that 2 tasks were processed. 2 times the count to 10 task, and we got the result task done, with the runtime of 10 seconds. Alright, we can also check in our results backend. So task results. And we can see here the 2 task results saved in the database with the success status. Great. And finally, let's also test the beat container by scheduling the send newsletter task. So I set up a schedule in the periodic tasks table here. Create a new task. Name send newsletter. I select the send newsletter task. And add a cron tab schedule. And I will trigger it on the 12-minute mark, which for me is in 1 minute. And save. Now inspect again the console in the Celery container. And here I'm waiting for the task to start. There we go. The task started and is mimicking to send a newsletter to 10 recipients. Nice. We can check it in the Flower interface as well. We have 3 tasks now. The most recent was the send newsletter task, and it returned the result completed. And the result was also saved in the backend. Awesome. Alright, this is all for this video. Thank you so much for watching. You should be able now to containerize an application with many services, at least in a development environment. In the next video, we will see how we can prepare this application for production and deploy it to a web server. I hope to see you there. Until then, stay curious, my friends, and bye bye for now.